These are the first three problems on this week's study guide for Algebra B, Test 4, Quarter 2. First one talks about a car leaving an airport flying north at 60 miles an hour. 3 hours later, a plane takes off from the same airport, flying north, same direction again, at a whole lot faster speed, 618 kilometers an hour. And they ask, how far from the airport will the car be when the airplane catches it? Well, one thing we know about this problem is that if we draw a little picture, we've got the car leaving the airport, driving north, and then the airplane leaves 3 hours later and drives north. And when will it catch it? Well, what we don't know is, and that's what we're going to find out, is how far from the airport it will be. We don't know that distance, but we do know that distance is the same for both the plane and the car. And so that's going to be a key thing. We're going to end up with the same distance, since they are saying or asking, when will the airplane catch the car? So catch just tells us that we're going to have that same distance. So let's start off by writing our two equations. We've got our car equation, and we've got our airplane equation. I'll just write plane for now. And it's going to be a distance equals rate times by time. Well, most people like to fill in the rate first. That's what's given to us. Those are the numbers, at least, that are given to us. So the car is going 60 miles an hour. The plane's going 618 miles an hour. And we talked about before how since the airplane and the car are going to be at the same place eventually, we're going to use the same variable to represent that distance. We don't know what it is, but we know it's the same. So we're going to use the same variable, d. And also, we know something about the time here as well. See, the airplane leaves 3 hours later. So we don't know how long the car is driving for, so let's call t the time the car is driving for. Well, the airplane is going to be 3 hours after, so later means minus 3 from the amount that we already have, well, which is a variable in this case. So it's going to be t minus 3. Anytime you've got an expression for the rate or the time, put it in parentheses because you have to multiply the two. So here's how we're going to do it. We've got our two equations, d equals 60 times by t. We're going to take that expression and we're going to put it in place of d in the plane's equation. So take that 60t and let's put that in place of d using substitution. So let's rewrite our equation. It goes 60t and then equals 618t minus, now we've got to multiply this. So this makes 24, and then that makes 3 plus 2 makes 5, and then 3 times 6 is 18. So from there, just a little opposite operation problem. Subtract that 618 from both sides. And make sure, again, whenever you're subtracting, especially with equations like this, we set up the problem this way, but we always got to put that bigger number on top when we do that subtraction. And then we go ahead and do that. 618 minus 60 leaves us with 558. So 558t. And that's a negative number also. And this all equals this negative, make sure you bring down that minus sign there, and it's negative 1854. So from that point, just one division problem, and it's not going to work out as a clean number. We're going to go ahead and do the division, and we end up with a decimal. And so I'm just going to use a calculator to figure out what that is. And actually, on the directions on your page, it does say round to the nearest tenth, or nearest whole distance. So I'm not going to round quite yet. And my time is going to be a decimal. When I do that division, 1854 divided by 558 gives me 3.32, and then the decimal keeps on going. So I'm going to write the whole number down. Now, if I have a calculator, I'm going to go ahead and use the numbers it gives me. And I'm not going to round that number until the end of the problem. So I'm just going to use that number as I go ahead and substitute it back in. So this is the number of hours. This was my value there, hours. And I'm going to put that in place of t in this equation. So I'm going to use that same number. I'm not going to round it. I'm not going to change it to 3.3. Otherwise, we're not going to get as accurate as an answer. So I'm going to use that exact same number, 60 times by, and then I'm going to use the 3.3225806. So I don't erase that off the calculator. I leave it the same way, and then I go ahead and multiply it. And when I do that, I end up with this number, 199.35, and then it goes on. And it doesn't really matter what these numbers are. These are let's see here, it goes 35483. And so I don't need these extra numbers. They said to the nearest whole number, basically. So what I'm going to do is I'm looking at the tenths value, and that's not big enough to round it up. So I'm actually going to round down, and I'm just going to round this to 199 kilometers. And that would be my answer. So that's one thing that you should remember whenever you're rounding, is don't round until the end of the problem. So I just leave those numbers in the calculator and use those. Well, let's try another one here, number 2. This one is another plane problem. So this one's different, though, because it talks about wind speed. And so we're going to have a plane that flies 900 miles with a tailwind. So whenever we see, okay, I've got wind speed, or it's a boat problem, you got current, that means that you're always going to set up two equations. And typically we go with the wind, and that's what we have with a tailwind. So whenever you see the word tail, that means that it's going to be at our tail. It's pushing us. Typically, we're going to go against the wind on the way back. Now, we've seen some problems where they recalculate their flight time both against the wind. So we've got to read the problem further. But it does, after the second sentence, it says it takes 4 hours to fly the same distance against the wind. So they typically call this a headwind when we're going against the wind, but I'll just write against wind. So we can go ahead and write down our formula. It goes D equals R times by time. And we can go ahead and fill in some information. Now, remember, when it says a tailwind, or when you're going with the wind, that means that we are adding the wind speed. So we call the wind speed W, and then we also have another speed, and that's called the plane speed. And that's what they're asking for here. The plane speed, we're going to use that as R. So we're going to say the plane speed equals R. And so we've got 900 miles, so we can put that in for distance. Miles would be distance, equals, now the rate with the tailwind, we have the rate of the plane, R, plus the rate of the wind. So there's always going to be two components that we don't know in these problems. In this case, it's a rate of the plane and the wind. And it took us 3 hours to do this, so we'll put a 3 right there. Now against the wind. So 4 hours for the 900 miles when we're going against that wind. So that wind's pushing us back. It's working against us, so it makes it harder for the plane to go. Well, the plane's going using the same amount of acceleration, so it's going, but the wind is pushing it back, so it's not going as fast. And that's when we end up doing R minus W. And so from there, we can go ahead and solve. You could distribute, but as I look at it, it looks like I can use that method that I had used in the past with these problems, which is to divide or multiply by the reciprocal and eventually divide by that time in this case. So I'm going to go ahead and do that. I'm going to multiply this side by 1/3, and that will cancel out these 3's. And then do the same thing on this side. And when I do that, 3 goes into 9 3 times. Bring up those hundreds. So we've got a new equation. This equation is going to be 300 equals R plus W. Let's do the same thing for this one. Let's multiply by its reciprocal, 1/4. And so let's do the same thing on this side, 1/4. Now, 4's cancel out. Now 4 goes into 9. It goes in there 2 times. And we have 1 left over, so we put a little 1 there, and 4 goes into 10. That goes in there 2 times, but this time with 2 left over. So it's going to be 20. So 4 into 20 goes 5 times. So 225 is the number you get, equals R minus W. And the nice thing about this problem right now is it's set up for elimination. So we can just add these equations together, and we'll just have one step to do to solve. So this is the part that you got to watch. 1R and 1R make 2R's. Again, the W's canceled out, and that's what what you have to do with elimination. You've got to be able to cancel out one of the unknowns. Well, we add this stuff together. 525 is the number. And it doesn't quite go in there evenly, but that's okay. We do the division. And we'll divide by the 2 on both sides. And we'll get our answer. So R in this case equals 262 5/10. And this is in miles, so it's miles per hour. And there is our answer. Well, that's all it asked for. It didn't ask for the wind speed, so we'll just leave it like that. We've got one more problem. And this last problem is a mixture problem. So mixture problems are a little different than these rate problems. We set them up this way. I make the chart still. And so what we have are 2 different parts. We've got like part 1, we'll say part 1, and then we got part 2. And we're taking these 2 parts and we're mixing them. So this is the final mixture on this last part here. And now up above on these percent problems, we always start with an amount of solution. And the amount of solution is, depends on the units. In this case, it is in gallons. So sometimes we could write that down too. It tells us what units we're in. So we'll write that in there, gallons. And then we're going to multiply this by a percent. And the percent is of salt. Now, what I like to do is I like to leave it without the decimals. And so I'm going to go ahead and when I do my division, or when I multiply my percent by the amount, typically we're going to end up changing those percents to decimals, but I like to leave them in the percent form so I don't have to deal with the decimal. So when I go ahead and multiply these, I get an amount of salt, but I've got to specify that this is times by 100. Now our final answer will be the correct answer. We don't have to do anything to it. But it's not really the amount of salt. This is the amount of salt times by 100 because I'm not changing that percent to a decimal when I do it. But what we'll end up doing is we'll end up adding the 2 parts together of the amount of salt and coming up with setting that equal to the mix. So let's go ahead and read what we've got. It talks about how many gallons of a 70% solution should be mixed with 40 gallons of a 23. So how many gallons? We don't know. So that's our X right there. How many gallons of the 70%? We don't know, so X of the 70%. We go ahead and multiply those. That makes 70X. Then over here, must be mixed with 40 gallons. Well, that's the amount of solution, 40 gallons. Must be mixed with 40 gallons of a 23%. So 23. Well, we go ahead and multiply those 2 numbers, and we get 920. And then to obtain, that means to get the final mixture here. So we know this is going to be the mix because it says obtain. A mixture that is 60%. So it only gives us this, and that's okay. We're going to write an expression to represent the mix. These 2 always add to make the mix. So we're going to take X gallons plus 40 gallons, and it's going to make our final mixture. Well, anytime we've got an expression, put in parentheses and distribute. So we go ahead and do that. We get 60x plus 2400. Well, now we're ready to solve. Remember, this is the amount of salt. So these 2 parts are going to add together to make the final. So it's the amount of salt times by 100. That's why the numbers are so big. And so 70x plus 920 equals 60x plus 2400. And so we just go ahead and do some opposite operations there. And I'll subtract that 60x from both sides. And I'll also subtract that 920 from both sides. And so when I do that, I end up with just about my answer. I have 10x equals, and then I do that subtraction, I get 1,480. And so I just have one step there of dividing, and do that next here. Move this back up here. my last step of dividing there, divide by 10 just moves that decimal over that one space. And so I get my final answer of x equals 148, and this is in gallons. And so it's going to take 148 gallons of that 70% solution to end up making it work. And so there are the answers.